What is a contingency table and how are they related to probabilities? Welcome to My Finance Teacher, and by the end of this video I hope you'll be more familiar with contingency tables and you will be a step closer to being ready for your test on probabilities. By the way, I heard that liking this video really helps you with that test. I don't know, but why not try that? First of all, what is a contingency table? Contingency table is a table that basically summarizes your sample, summarizes your data by a couple of variables. Usually that's a couple of variables because representing more than two variables is a little bit tricky. In our example, we have a table which summarizes our sample by two variables. We have number of movies watched per week over here going across the rows, and we have age over here going across three columns. And these variables are actually classified into categories. The variable age, as you see, is classified into three categories: under 30, 30 to 60, and above 60. And the variable on the number of movies watched is classified into 0, 1 to 2, 3 to 5, 6 or more. So here's our example of a contingency table. And in order to see how exactly are they related to probabilities, let's practice by answering a few questions related to this table as well as probabilities. Here are the 5 questions that we're going to answer. As you will see, these 5 questions sometimes require finding conditional probability, sometimes they require adding or multiplying probabilities. And for all of those operations, we have some hints over here with the formulas on your top right. Remember, for addition we have special and general rule, and for multiplication we have special and general rules of multiplication as well. And before jumping into answering these questions, let's add one more row and one more column to this table. Let's add the totals. In an additional column, let's add the total by movies. So for example, the total number of respondents within the sample that watched 0 movies per week across all ages is the sum of these 3 numbers. Similarly, I'll just copy this formula down the column to find the totals by movies watched. Next, let's do the same to find the totals by age. For example, let's find the total number of respondents who are under 30. Same for this age group and the next. I'll just use this simple Excel formula and copy that across the age groups. Now it will be much easier to answer these questions using some simple formulas. So let's jump into these questions. First, what is the probability of selecting a random adult who attends 6 or more movies per month? In this question, as you see, we're not concerned with age at all. So we're only looking at number of movies across all ages without any concern for particular age category. So the total number of respondents that watched 6 movies or more is 50. And to find the probability of selecting one of them at random out of the total number of all of the respondents, we just need to divide this 50 by the total number of all of the respondents. So let's find that total by either adding these column numbers or the numbers in this row. Either of those, of course, give us 500 total number of respondents, and the answer to the first question is 50 divided by 500, which gives us 10% chance. Next, moving on to the second question, I'll use this squiggly wiggly thing to denote the same words that appear in each of the questions, which are selecting an adult who attended. So find the probability of selecting an adult who attended 2 or fewer movies per month. So this question is similar to the first, where we don't actually look at a particular age category. 2 movies or less requires us to add the probabilities of selecting a random person who has watched either 1 or 2 movies, in other words, who is in this category, or selecting a random person who is in the 0 number of movies category, who's similar to the first question, the person is in the 0 category with the probability of 75 divided by 500. So we need to add this probability to the probability of the person being in the 1 to 2 movies categories. That probability is 200 over 500. Now, looking at addition of probabilities, we have a couple of rules here. We use the special rule in this case because being either in 0 category or 1 to 2 movies category is mutually exclusive. I can't at the same time watch 0 movies per week and a couple of movies per week. Hence, to add the probabilities, I simply add them as they are, which gives me 55% chance. Next, let's jump into the third question. Find the probability of selecting an adult at random who attends 6 or more movies per week or is 60 years of age or older. Again, when we have a question that says or, we want to add probabilities. In this case, watching 6 or more movies and being 60 years of age or older are not mutually exclusive. So we will use the general rule of addition of probabilities. Let's first find these probabilities one by one. Selecting a person who has watched 6 or more movies, as we've seen from the first question, it has a 10% chance. So our first probability is 50 over 500. The second probability of being 60 years of age or older refers to all of these respondents in the third column, where we have 175 respondents out of 500 respondents. The ratio of these numbers gives us the probability of selecting a person of that age. Now, to use the general rule of addition, we add the probabilities as they are and subtract the joint probability of any random respondent being both in this age category and watching 6 or more movies. That refers to the intersection of the corresponding row and the corresponding column, which intersect at this number 30. So the joint probability that we have to subtract is these 30 respondents divided by 500. Because adding everybody in the column plus adding everybody in the row actually counts this number 30 2 times. That's double counting. We want to subtract that to avoid this double counting. So this is the formula for our calculation, giving us a 39% chance. Next, moving on to question number 4. Find the probability of selecting any random adult who has attended 6 or more movies per week, given that the person is 60 years of age or older. This question requires us to find a conditional probability. Given that we're only looking at the respondents who are in this age category, we want to find the probability of a respondent from this group watching 6 or more movies per week. The total number of respondents within this group is only 175. And within this group, given that we're looking at only this age group, the total number of respondents watching 6 or more movies per week is 30. So the probability of randomly selecting one of those 30 out of only this age category is a ratio of 30 to 175, which gives me a 17% chance. And lastly, looking at our last 5th question, let's find the probability of selecting any random adult attending 6 or more movies per week and who is also in the age category of 60 years of age or older. Generally, when we have a question that includes the AND word, that often refers to multiplication of probabilities. To decide which of the rules of multiplication we have to use, we need to decide whether the categories are independent or not. I think the categories here are not independent. Looking at frequent movie watchers, we see that usually the age does affect the number of movies people watch. In most of these rows, the youngest generation usually watches the fewest number of movies, except of course for zero movies category, where the older generation has the smallest representation. I think generally what this table shows is that those who are under 40 don't watch as many movies. So the age and number of movies watched per week are not really independent in this case. So we're going to use the general multiplication rule to find the answer to problem number 5. First, let's find these separate probabilities. Selecting a person at random of 6 or more movies has 10% chance. And secondly, let's find this conditional probability in the right-hand side of this formula. Let's say event A refers to a respondent watching 6 or more movies, in which case event B refers to a respondent being in the 60 plus age category. So this conditional probability is the likelihood of being in the 60 plus age category given that we're already looking only at the category of people watching 6 or more movies. So given that we're only looking at this row, what are the chances we select a person in the 60 plus age category? The total number of respondents in the 6 movies or more category is 50, and there are 30 60 plus aged respondents in that movie category. So the conditional probability is this 30 divided by 50. Which gives us 6% chance for this last question. So that is how you can use contingency tables to calculate the probabilities of selecting respondents in particular categories. The main point here is to understand the question and choose the correct formula for addition or multiplication of probabilities. Good luck on your tests.